The last section in chapter 10 is where we talk about vectors, which will come up a lot in physics. So, vectors is just another way to describe measurement in some sort of direction. Intuitively, I want you to think about like force or velocity. So, with force, you're pushing or pulling in a direction. So, push, pull in a direction. And with velocity, you have speed and direction. So think about those things when you're thinking about what a vector really is. Visually, it's just an arrow in space. So this is a vector. So here you have your initial point. Here you have your terminal point. And the vector itself is the arrow connecting those points. That's all that it is. There's a couple ways to write a vector in terms of notation. A lot of times we use an arrow above the name of it, or we use bold font. Sometimes it's really hard when it's handwritten. So here are a billion different ways you might see it. It might be like this weird half arrow. It might be a full arrow. It might just be a line. So those are all different ways to write a vector. The notation, however, is going to have these weird angle brackets. Angle brackets. So keep that in mind, where these are obviously coordinates, and that is different. So the vector for -1 can be drawn really anywhere, but the easiest way to do it is from 0, 0 to 4, -1. So here, 0, 0, 1, 2, 3, 4, -1, and then we draw an arrow connecting them, and the arrow is the vector. You could shift this anywhere on here, and it would still be that same vector. It would just have a different initial and terminal point. So let's think about an example where the initial point is 2, 4, and the ending point would be 6, 3. So if that's the case, we would have the terminal point minus the initial point of x, and then the terminal point or the finishing point and the initial point of y. That's just 6 minus 2 and 3 minus 4, which still ends up being 4, -1. So it's all the same. It's really just the arrow, which happens to have that same distance and direction. If you want to do vector addition or subtraction, it's honestly pretty straightforward. You are going to add the first terms together, and then you are going to add the second terms together, and then leave it in vector notation, essentially. So for u plus v, we have 3 plus -1. So 3 minus 1. And then we would have -2 plus 4. So we would have 2, 2. Subtraction works the same way. So notice the only difference is that you are going to be subtracting those terms. So we have 3 minus -1 and -2 minus 4. So we end up with 4, -6. If we want to multiply, it's essentially just distributing the multiplier to both terms, and then it maintains vector notation. So here we have 3 times -1, 4. So -3, 12. Here we have 1/2 times -1, 4, or -1/2, and 2. And here we have -2 times -1, 4, or 2, -8. Nothing crazy there. Combining these concepts, if you want to find a new vector like W, which is a sum of two different vectors and they were multiplied by something, we do both of those things. So we have 3 times the first vector plus 2 times the second vector. And then we have 9 and negative 6 plus negative 2 comma 8. And now we're just combining the first terms and the second terms. So 7 comma 2. 7 minus 2. 9 minus 7. 9 minus 2 is 7. I'm doing too much. Negative 6 plus 8 is 2. There we go. We also have the dot product, okay? That is the product of the horizontal components added to the product of the vertical components. So you're gonna multiply the first things and then add the multiplication of the second things. And the order here doesn't matter. You could do BD plus AC or AC plus BD. It does not matter. So U dot V, this is not multiplication. This is a dot product. So this is a dot, not multiplication. We're going to have 3 times negative 2 plus negative 4 times 3. Notice that this is not a vector. This is going to be just a number, or also known as a scalar. Just a scalar result. We also can calculate magnitude. Think of this as its length. Think about the hypotenuse of a triangle, right? You're going some distance this way or this way, and then some distance this way. And so that hypotenuse is essentially what we're finding now. So you're going to treat this like you would your Pythagorean theorem. It's going to be the square root of 3 squared plus negative 2 squared. It's going to be the square root of 13.